So the next topic we're going to cover is going to be adding I/O modules and other remote devices via Ethernet IP. So as you guys are aware, more and more devices are having the ability to integrate and communicate to a platform such as a Rockwell controller and even outside of our platforms. So having the ability to see what you're talking to, get the diagnostics from those devices, and the individual control has become an important factor. So that's why Rockwell, when they made the I/O hardware configuration, has made it so that you can now see and diagnose things through the I/O platforms, whereas previously you could just hook anything up. As long as you get the physical input that the controller was looking for, it will still execute. So going through the I/O tree a little more specifically. So you will always have your local chassis. So for a ControlLogix, which is this chassis, which is 1756 platform, you have an L7, you will have a hard configured. So this is a A10, which is a 10 slot chassis, which means you can only have 10 local cards no matter what. When you're talking about the compact Logix, there is no hard configuration. So you will see just a controller and then the amount of I/O. For today's demonstration, I actually have a 5069 controller. So it's a compact Logix. So I will be able to show you that there is no finite chassis size and that you can configure everything independently as you're going through. But the other thing is you can add remote I/O, which you will add a Ethernet adapter of some sort to communicate back and transfer I/O. So remote I/O, even though it is under your Ethernet settings, it uses what they call class 1 communications, which is different than, say, messaging or a panel view or an OPC. All those communication types are a class 3 communications. So class 1 communications will always take priority. It is always faster. And it is more reliable. And that's why we are able to get better speeds and better accuracy and the diagnostics for remote I/O as opposed to using messaging or some other class 3 communications, which is slower. In order to add objects to it, you can either add it to the Ethernet here, or you can click on the backplane if you're adding a local card. So it depends on where you are adding your individual thing. So module discovery when you're online, this has been around for quite a while. It is now fixed. So with version 32 and with the newer hardware, they have definitively fixed this module discovery. In my past, I have had it where sometimes it would work, sometimes it wouldn't. Now with the newer controller and the newer software, they have fixed it, and I'm actually going to show you how that works today. But when you are creating a new module, there are a couple of configuration and a few things you want to look at when you're looking. So the catalog number is what you will select. So I'm going to go back up one. So when you do new module, you can click on the module and then add the profile that you want. So for this individual one, we're adding a 16-point high-speed DC input. You will have to give the module a name. The module name must always be unique, even if it is on a remote rack. So you cannot have a local card called analog input 1 and a remote card called analog input 1. It will fail on the second one when you attempt to make it, because the controller uses that information for those diagnostics that I was talking about previously. You will always assign a slot number. So again, for the ControlLogix line, you'll have a finite chassis, so you'll know exactly where it is. For a compact Logix, you could have either an address reserve module, so an ARM module, or you can put it on the end of the existing chassis, in which you will have to look at your I/O configuration or physically look at the setup to determine what is an available slot number for you, because it doesn't have that finite amount. And then there's always this module definition portion. So one thing that is key would be the keying. So when you create a new module, you can have an exact match, which means the catalog and revision number must match to the EDS file. So when you plug that module in and the controller pings that device and gets a response, it will automatically check what the catalog number is, and it must match identically. So if there was a series change, anything like that, it must match. So say that they had a controller or an IO module that they bought and initially installed, and then 10 years later you're replacing it, and they've gone through a series change where the initial one was the 1756 IB16F, but it was a Series A right here, and you are now a Series B. That must match, otherwise it will break your controller or stop the communications to that individual device. And the other thing is the revision here. So the revision of the firmware on that device must also match. So that's the exact match. That's really useful when it comes to automatic device configuration. So for IO modules, most people don't want to do that. For drives, servo motors, things like that you will have added into your controller, exact match makes it nice because you have the ability to download the configuration from the controller in the event that they change that device. And in order to do that, it must be exact match. The most common and default is compatible. So that one will just say, does this match in enough that the functionality and the way that this module is works? So if the series changed or the revision changed, but the device itself is still the same, that's okay. I'll let it still go. And then there is disable. So disable will always attempt to connect to the device regardless of what the device is. So as long as the device communicates, then the Rockwell controller will say, okay, it's actually communicating, it's fine. I don't necessarily care what's out there. Some third-party companies and stuff like that do not have their EDS file set up properly or things along that nature, and therefore they require you to disable keying because the controller never gets the proper response of what it is looking for. So in the event, that's where that disable keying comes in. That turns it so that you have almost a dummy type setup where you can add anything, and as long as it communicates, it will work. The next kind of major portion inside the controller will be the configuration. Now, each of these tabs here along the top are specific to each module. So depending what the module is, they're going to look completely different. For today's event, we are going to be adding another module to my chassis that is currently not configured because we're going to discover it or look for it that way. So I'll show you again what you have, but the general tab will always be the same. The connection tab, the next one over, that is where you have the ability to inhibit, which means you can tell the controller, do not look for that device. That comes in useful if you know that you are going to fault a controller by pulling some sort of device. So with compact logics and control logics, you can remove or exchange cards and nodes while powered up. So you can inhibit that device, pull it out, know that the card's bad or something like that, and then you could put a new one back in it, and as long as it was set up for a compatible or it matched identically or however it was, right, you can plug that back in, then uninhibit, and everything will start working. But if you don't uninhibit, you could potentially fault the controller, which will stop everything and put it'll stop the outputs and essentially stop executing the logic. Then there's also configuration based on this one's an analog input, and then there's other things, alarming and time sync. But again, each module has different tabs, so you'll have to look when you create the module, what tabs does it have. Another new property that came out with version 32 is you have the ability to delete an entire nested setup. So historically, if you had a complete chassis out there, so a 1756 had a remote IO chassis where they were sending all this IO, and you have removed it at one point. So you had a pause here, which means it was inhibited. They had removed it in the past at some point in time. It's very easy now to delete it. You can simply delete the partner or the parent, which would be the Ethernet drop here, and it will delete all the children or all the individual cards also. In the past, what you would have to do is card by card, delete every reference inside the PLC, and then delete each individual card until it was empty, and then you can delete the parent. So now when you delete the whole thing, it will show up as warnings for you, letting you know, are you really sure you want to delete this? Because it's going to delete everything else, and it will then cause faults inside the process. So you have to, but you now could filter on those errors and delete those tags out quicker, whereas before you would have to know exactly and go find it each time. So the next topic we're going to cover that kind of is somewhat related to the IO itself, because the IO will create its own tags. That is due to the module, adding the module, which is an add-on profile. But tags themselves inherently have two styles. So you have controller scoped tags and then program scoped tags. So the primary difference between the two is a program scoped tag cannot be referenced in any other routines that are not in that same program. So the logic I have that we're going to review later today, we have multiple programs. So in the event I wanted to have that same tag multiple times, such as a simple word as start and running, you could have those as a program tag. Whereas a controller scope tag, if you have a word or a tag called start, nowhere else in the program can you have a tag called start. So that is that's the primary difference between the two of them. Both controller and program scope tags can be accessed from outside. So an OPC or an HMI or something like that, it can still get to both of them. So that's not a hindrance there. It's just whether you want your individual routines to be more modularized. With the tag editor, if you double click on any of the tag editors, it will open up a window, a tag browser. You have the ability to monitor tag and edit tags. So monitoring will show you live values of what's happening, things along that nature. Edit tags allows you to potentially, if the tag is not being referenced, change the name of it or delete the tag or update the tag name, things along that nature. Inside the tag browser, you can change the scope. So even though you double clicked and opened the controller tag here that's highlighted, and it by default will pull a controller scope. So our controller is called IO test. You can select the drop down and say, oh, I actually just want to look at main program tags. And you can select it here and change it without having to go open it up, unless you want to have both open at the same time. So since you open the controller tags and you want to compare that to the main program tags, you can come down and double click the main program tags right here, and it will open up a separate window for you so that you can have both open at the same time. The other thing that is incredibly helpful is you have the ability to filter, which they have slightly hidden right here, and you can show specific tag types. So in this show tags, right now it's show all, but you can filter that to be, I want to see only message tags, or I want to see produced and consumed tags, or I want to see any tags that are unused to determine if someone created a tag that wasn't really needed because I'm cleaning up a controller. This right here, this show tags, has a different filter type. So this filter here, you filter based on the name, whereas this filter here can filter based on the type. So they're two separate ways of filtering. Most common is going to be just filtering based on the name, but in the event you want to find a specific style or type, you can filter that way also. So this kind of goes over a little bit more controller scope versus program scope. And again, produce and consume tags will need to be controller scoped. I didn't mention that earlier, but they always need to be. User-defined tags, add-on instructions, and add-on profiles all are always controller scope tags. But the program scope tags, again, allows you to have the same tag name to be reused because it is only used in this routine within this program. The other thing here, though, that this does highlight, as there are what they call atomic, but what I would call built-in tag types. So you'll have Boolean, integers, double integers, reals, strings. They have tag structures, but there are pre-built structures such as a timer, a counter, and a message. Another structure type, though, is a UDT. A UDT is, again, a user-defined tag type. So inside a user-defined tag, you can have multiple tag types. So we'll kind of quickly run through that during our demonstration, but you can have multiple Booleans, double integers, and strings all in one, and it'll show as one tagged style. This is really useful for doing produced and consumed, so you can send multiple pieces of information inside of one tag type, because produced and consumed tags are an individual tag on both ends. And then the other thing would be arrays. So you always have the ability to create arrays. By default, most people deal with a single array, but if you add a comma and then a next one, you will actually create a matrix. So you can have a 2 or up to 3 dimensional matrix. Most programming doesn't get into that depth and detail, but just wanted you to know that you have the ability to create a matrix as opposed to an individual column, which would be an array. So another enhancement that's also come out recently is if you have a user-defined data type and you want to change the tag name of one of the tags inside your user-defined type, you can now do that while online. Previously, you would have to delete the user-defined type along with any reference to it in order to create a new one or make changes. So it was a pretty painful process. Now you have the ability to change that without having to delete or go offline or anything like that. So it gives you the ability that you want to design UDTs with excess memory. That way you have that extra in case I need to add something, I have it available to me at any point in time. The last section we have in this group of topic here is going to be the difference between tasks, programs, and routines. So all code for Rockwell is structured into 3 setups. So you have a task, a program, and then routine. So the routine stores the actual code that's going to be executing. The other 2 are almost a folder setup. They're not an actual folder style, but that is supposedly coming with newer releases. But you have this 3-layer. To get any execution of program, you have to have the 3. So for a task, there are 3 styles of tasks. And as you can see, they have 3 different icons. So a continuous task will look like this. A continuous task runs in the free time, so to speak, of a controller. The continuous task is typically not recommended. So with newer code, most people can set up a periodic task to execute very, very quickly. So this periodic task we have here is running in 1000 milliseconds or every 1 second. That is slow. By default, it sets itself to 100 milliseconds. If you need something faster, you can still go a little bit faster, but the maximum for the new style you can go is 2 milliseconds. I don't know that you would ever need to run faster than that, but some cases do, in which you can still use a continuous task, but the continuous task is not guaranteed to run. So a periodic task will actually take precedence over a continuous task. So a continuous task will always attempt to run if the controller is not doing something else. With the new style controllers, continuous tasks aren't as detrimental because there is a core dedicated to executing the logic independently. Whereas the previous one, it would have to do communications, housekeeping, so to speak, and IO and the routines all in one core. So it would toggle between each of those tasks. And if you're telling it to run the routine continuously, it would pause, run to a periodic task, finish that, and then jump to everything else, and then come back and run that when possible. So it still gives you the best speed possible outcome, but is not structured to run properly like you would think. So that's why we ask people to use a periodic task most of the time, where you run it as a predefined period, and it does take priority over the continuous task. The last type is an event task. Common use for an event task would be in the event that an operator goes to a different level. So you have one controller that has 2 separate HMIs or 2 separate control stations. if the operator goes upstairs, they can flip a switch and it will execute and use the IO from that up there to use your programming. So that is, it's kind of a weird way of doing this, but you can tag it to a local input. So in the event that they flip the switch, they say, I'm actually at control station 2. They flip a switch, your code will no longer look for the inputs coming from downstairs, but will now look at the inputs coming from upstairs. So that's a one way that you can use event task. There are other situations you can use it, but event task always gets triggered, right? So it will not execute unless it is told to do so, and it will only execute as long as that condition stays true. So that's where an event task will come in. Most common practices, you're going to see periodic tasks, and occasionally you will see a continuous task. But again, we urge people to use a periodic task. So inside a task, you'll have programs. So programs are how you can modularize your code. So you can have a program based on individual lines. You can have a program based on individual areas. There's all sorts of reasons on where and why you would have multiple programs. But programs are assigned to the task, so they will execute based on the task schedule. You can have multiple tasks per task, which is very common again. But the main purpose for a program is just to simply create a structure to hold tags if you want them for local tags, as well as independent routines, which are where your program executes. One key thing that I point out here in this bottom one, so every program must have a main. It doesn't need to be called main, but it must have a routine that will always be executed, and it is shown as the number 1, and it will always execute first. The rest of them do not need to be in proper chronological order. Inside that main here, you will have you are required to have a jump to subroutine, and that is where you will tell it the order in which you want the code to execute. But the very first one, the program must know I will always run a routine, and it has to be declared, and it's declared at that program level. So up here in the properties of the controller or the program. And then lastly are your individual routines. So routines are pretty straightforward. They are just where the real work, so to speak, is done, or that's where the code is actually implemented and executed.